1,1,1 tribromo, 2,4-dichloro, 2,6-difluoro, 3-iodo, has 4,5 diene. Good everyone, once again I welcome you all to my YouTube channel. And in this particular video, I'll be teaching you on how to name organic compound. This is actually an introductory video on naming of organic compound. I've been getting a lot of questions lately. That's how can we differentiate alkane, alkene from alkyne? Let me show you something. Alkane, this is alkane. This is alkene, and this is what? Is alkyne. So this is part 1 of this video. We are going to go to the part 2 of it. So we have CnH2n plus 2 for alkane, CnH2n for alkene, then CnH2n minus 2 for alkyne. So this is their general formula. Another thing again you should take note of, this guy here, which is alkane, it is saturated. It's a saturated hydrocarbon. This is unsaturated. And this is what? Unsaturated. Okay, you can also call it super unsaturated. So that's another thing again. The hybridization of alkane is sp3. Here is sp2, and here is what? sp. This is their hybridization. The other thing we should take note of is the structure. We can talk about their angle, linear. Okay, let's say this is tetrahedral. This is trigonal, and this is what the shape is. What is linear? So let me go straight to the structure. Alkane, we have one. Let's deal with 2 carbon atom. Now, this is the correct structure of alkane. But before you understand it, there's something I want you to take note of. Carbon is usually tetrahedral. That is to say, every carbon atom must be bonded to 4 bonds. Must have 4 bonds. One must be bonded to 4 atoms, anyone. So must have 4 bonds. If you look at this carbon atom now, let's count the bond. This is 1, 2, 3, 4. Look at this one. 1, 2, 3, 4. So if carbon is not bonded to 4 bonds, that means that carbon atom is not stable. So generally, your structure is not what? Is not stable. Now, for the structure, for this other structure, we said, let me draw alkene structure first. Let's start with alkene structure. So for you to form an alkene, which is a double bond, there must be a double bond here. And for this double bond to be formed, this single bond, there will be a homolytic cleavage. What I mean by homolytic cleavage is that this bond is going to break. Here, one atom will come here, one atom will come here. Sorry, one electron will come here, one electron will come here. While hydrogen here, we have 1 electron. This hydrogen have 1 electron. It will become a free radical. But I don't want to go into deep part. This is just the basis of the class, so I don't want to go deep. So, in other words, what I'm trying to say now is that for a double bond to be formed, these 2 hydrogen, you have to clean it. Then you put 1 bond here. So this is a double bond. And if I want to form a triple bond, let me draw an alkane again. Here is hydrogen, 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 and here is hydrogen. For me to form a triple bond, I have to clean this. I will form a double bond. I will not clean the top again. I will form a triple bond. So this is how you form your structures. So please, just take a look at this again. And if you have any question on this first, you can drop that in the comment section. Welcome back. If you have a structure of an alkane, let's say 1, 2, 3, 4, 5, 6, and is bonded to S. This is an alkane. The reason why I call this an alkane is singly bonded. It's bonded to S. S simply means chlorine, bromine, fluorine, and iodine. So what I mean by that, S is represented as what? As the halogens, which is group 7 elements. In organic chemistry, you cannot call chlorine, chlorine, bromine, bromine, fluorine, fluorine, iodine, iodine. You call them chloro, bromo, fluoro, and what? Iodo. So if you have S here, it is called alkyl halide. Alkyl halide, because this is an alkane. When an alkane that loses 1 hydrogen atom is called an alkyl. So remember, the formula for alkane is H2N plus what? Plus 1, plus 2. But alkyl is CN, H2N plus what? Plus 1. So when alkane loses one hydrogen, it will become what? Alkyl. So how come it has lost one hydrogen? Let me give you the full structure. So here is hydrogen, 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 hydrogen. Now, if one hydrogen is removed from this structure, it is called an alkyl. And if it's represented by S, it means the S is what? Halogens. So you call it alkyl what? Halide. The reason why it's not called alkyl halogen is because it is bonded to an atom, so you cannot call it alkyl halogen. A halogen that is bonded to an atom is called halide. Free state is called halogen. Or you can also call this compound as what? Haloalkane, chlorohaloalkane, or halogenoalkane. So you can call them alkyl halide, haloalkane, or halogeno what? Alkane. Now, how do you name a structure? Please take note. If the structure has one carbon atom, it is called met. Two carbon atom is called what? Et. 3 is prop, 4 is boot, pent, hes, hept, oct, non, and what? And dec. These are some of the things I want you to take note of. So this is from 1 to what? To 10. So let's look at the carbon atom. 1, 2, 3, 4, 5, 6. 6 carbon atom. 1, 2, 3, 4, 5, 6. 6 is what? Is hes. So is it alkane, alkene, or alkyne? The answer is what? Alkane, because it is singly bonded. There's no double bond here. So we call it what? Hexane. But there is S here. S means what? Halogen, which is halogeno what? Hexane. Or halohexane. But let's assume that this hexane is now replaced by chlorine. So let's say here is what? Is chlorine. So you now call chloro what? Hexane. But if you still write something like this, they will mark it for you. But for me, I will fail it because you are not telling me the exact position of the chlorine. So where is the chlorine located? 1, 2, 3. It's located in carbon 3. If you count from this side, 1, 2, 3, 4. It's located in carbon 4. So if you count from this side, it's carbon 3. If you count from this side, it's carbon 4. So which side is lower? The answer is what? Is 3. So the answer will now be 3 chloro what? Hexane. But looking at this structure already, you know that this chlorine is closer to this side. So there's no need for you to count and count before confirming. So most structures, if you look at them, you tell us it is closer to the right or to the what? To the left. So that's how you know it. Let me show you something real quick. If you have something like, I will not be drawing hydrogen atom because of time. And here is bromine. Now, where are we going to put what carbon atom? How many carbon atom is present? 1, 2, 3, 4, 5. 5 is what? Pent. So pent. Single bond, double bond, or triple bond. Single. That's what? Pentane. Bromine here. Bromine is called what? Bromo. Then what is the position of the bromine? 1, 2, 3. 1, 2, 3. So it's position what? 3. Because if you count from the left, it's 3. If you count from the right, it's also what? 3. So the name is 3 bromo what? Pentane. But there are some situations whereby, let's say, another bromine is here. So where will you count from? If you count from here, it will now be 1, 2, 3, 4. But if you count from this side, it will now be 1, 2, 3. So from this side, we have 3 and 4. While from this side, we have 2 and what? And 3. So which of them is lower? Which of them has a lower value? 3 plus 4 will give us what? 7. Here will give us what? 5. So we work with the lower numbers, which is 2, 3. Bromopentane. But it's wrong for you to call it 2, 3 bromopentane. How many bromine do you have here? Is 2. So 2 will now be called what? Dibromo what? Pentane. Assuming it is 3, it will now be 2, 2, and the other value, tribromopentane. 4, tetrabromopentane. Let me show you something real quick. If you have something like 1, 2, 3, 4, and here is bromine, here is bromine, here is bromine. If you want to name this compound now, where are you going to start naming from? Is it from the left or from the right? I know that you are taking already. Tell me, where are we going to count from? Is it from the left or from the right? If you look at this structure, it's closer to which side? It's closer to this side. To this side, not this side. So let's count 1, 2, 3, 4. So we have uh, 2, 2, carbon 2. How many bromine do you have there? 2, 2. 2. Then we have another bromine here again. But if you count from this side, 1, 2, 3, 4. So we have position 2, position 3, and position what? 3. So you know that this value is higher than this value. So we work with this value. So how many carbon atoms do you have here? 4. 4 is what? But. So the answer will start with what? With butane. It's a single bond. So it will now be 2, 3, 3, tri, because there are 3 bromine there. 1, 2, 3. Tri bromo what? Butane. So that's how you get the structure. But for example, whereby you have more than one chlorine, like more than one halogen in there, chlorine might be there, bromine is there, fluorine is there, iodine is there. So how do you name it? You name them using ABC rule. That means alphabetical order. You start with the bromine, followed by the what? The chlorine, followed by the what? The fluorine, and lastly is the what? Is the iodine. So this is the law, the mechanism you follow while naming the organic compound for just the halogens. Welcome back. Looking at this table or looking at this structure, you realize that there are more than one halogens there. We have iodine, we have bromine, we have fluorine, and we have chlorine. That means all of them, they are completed. And another significant thing you take note of is that there is a double bond in the structure. Please, there is hydrogen. No, I just want to draw hydrogen, hydrogen. There's a double bond in the structure. So looking at this structure, there's a double bond here. Assuming yes, let me change to single bond first. Where are we going to start counting from? The answer is from the what? From the right, because all the structures are closer to the right than to the left. Now, as long as there's a double bond here, you don't need to ask yourself, where are we counting from? Is it from the left or from the right? No. The question you should ask yourself is that this double bond is closer to where? Is it to the left or to the right? The answer is to the what? To the right, because 1, 2, double bond. 1, 2, 3, 4, double bond. So you work with this one, which is from this side. So let's number 1, 2, 3, 4, 5, 6. So if you have a double bond in your structure, you are expected to work with the position of the double bond. If you have triple bond, it's the same thing. Single bond, you now start counting. So the work should be starting with bromine. What is the position of bromine? Bromine is located in 1. Any other bromine again? Yes. 4. 1, 4 dibromo. The reason why they are di here because they are 2. Then you put a hyphen. The next one here is what? Is chlorine. 5 chloro. 5 is what? Is chloro. Yes. The next one here is what? Fluorine. So fluorine will now be 3 fluoro. Then iodine. 2 iodo. How many carbon atoms? 1, 2, 3, 4, 5, 6. 6. You now write what? Pent. What's the position of the double bond? 2. Pent 2 in. Or 2 pentene. So the structure will now be, assuming here is single bond, just for you to write pentene. But as long as there is a double bond here, you have to tell us the position of the what? Of the double bond. So it will be 1, 4 dibromo, 5 chloro, 3 fluoro, 2 iodo, pen 2 in, or 2 pentene. These two here talk about the position. Any digit you see here is talking about the position of the dibromo. The dibromo is position 1 and 4. 1 and 4. 5 chloro, position 5. 3 fluoro, position 3. 2 iodo. Iodine is in position 2. Then pentene. Double bond is position what? Position 2. So this is how you name your structures. So what if you have something like carbon, carbon? Let's say here is bromine, here is bromine, here is bromine, here is chlorine, here is hydrogen, here is hydrogen, here is hydrogen, here is let me use, here is fluorine, here is hydrogen, here is hydrogen, here is hydrogen, here is chlorine, here is iodine, here is fluorine. So where are we going to start from? You notice that most of the halogens, they are in this side. Most of the halogens are in this side. So you count. But I don't need to count. If you count, you are still going to get the same value. So what we do, let's name 1, 2, 3, 4, 5, 6. So to make our work easier, let's circle all the halogens so that we know what we are doing. So that we don't get confused. The rest of the hydrogen. So if I want to name this now, remember, there's no double bond here. a single bond, not true. If there is a double bond, remember, I have to remove two what? Two hydrogen to put a double bond here. If I want to put another double bond again, I have to remove what? Another two hydrogen again. So I'm going to remove two hydrogen here. So I have two double bonds in the structure now. It's now called a diene. So let me work with something like this. Let's see where this can take us to. So remember, bromine first. Bromine is position 1. Is it position 1? Is it position 1? 3 bromine are in position 1. So you write tri-bromo. Let's look for chlorine. Position 2 and position 4. Dichloro. Then fluorine is there. 2, okay, 6. Difluoro. Iodine, 3 iodo. 3 what? Iodo. Let's count first. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's correct. Now, how many carbon atom is there? 1, 2, 3, 4, 5, 6. 6 carbon atom. 6 is what? Is his. What is the position of the double bond? Is it position 4 and position what? 5. Diene. So as long as there are 2 in, it's not diene. Assuming there is 1 in, it just be has 4 in. Assuming there are 3 in, has 3, 4, 5 triene. So that's how you name it. So the name of this structure now become 1, 1, 1 tribromo, 2, 4 dichloro, 2, 6 difluoro, 3 iodo, has 4, 5 diene. So that's how you name these structures. But please take note. I want to cram this. Note this very well. Met, et, prob, wood, pent, hes, hept, octanon, and dec. Know them very well so that you're able to name all these organic structures. And halogens, they are not called halogens, they are called halo in organic chemistry. So, and if you want to call bromine, it's called bromo, chloro, fluoro, and what? And iodo. And please take note. Follow the ABC rule. B, C, F, and what? And I. You don't need to name chlorine first before bromine. You name it following this pattern. So that's a general overview of how to name halogeno what? Alkenes. So in our next video on how to name organic compound, I'll be talking about how to name the alkyl functional group, talking about the methyl, the ethyl, and the what? Propyl. So I'm going to do all of this in our next video. If you enjoy what I do, please smash the subscription button and don't forget to follow Guido Academy on all social media platforms on Facebook, YouTube, Instagram, and on TikTok. God bless you. See you in the next video. But for now, goodbye. Before we say goodbye, please, if you have any questions based on this, go to the comment section and drop it. I'll be waiting for you to answer all your questions. See you in the next episode.